What's up? It's the Electrical DIY Coach. Just remember, never repeat anything in these videos and never work on an energized circuit. Let's get to it.
Let's go ahead and get started today. So today we're going to be dealing with a super popular topic, and it comes up very often on inspection reports, or if you're just in your home trying to make things safer. I'm really excited about this video, so let's go ahead and jump in. So the first way that you can satisfy an open ground, and I want to make a distinction really quick. So if you are in a location where there is a ground wire and it's showing open ground, then you're going to want to contact a qualified electrician, or you can check out some of the things in our videos to get some education, but you are actually just missing with a broken link in your ground connection back to the panel. That's different than what we're dealing with today. What we're dealing with today is if you have two-prong receptacles and the buyer saying, hey, I'm not going to buy it with these in there, or I want somebody to look at it, or if you're just wanting to make your home safer and you're wanting to be able to be allowed to install that third prong, or if you're in a situation where they do have three-prong receptacles already, but it's showing open ground and there's no ground in the box. So let's go ahead and jump right in. So the first way, number one, that you can fix an open missing ground situation is you can simply, or not so simply, just rewire the location. So you can bring a new cable to that location. You'll have a hot, a ground, and a neutral. You can hook up a three-prong receptacle with no problems. And the way you would do that is that it's in Article 210 of the code book. It's just a basic, wiring of branch circuits. You're also going to use Article 300 for your wiring methods. But that's probably, after I teach you everything that you're going to learn today, that's probably going to be the absolute last route that you're going to take, unless you're just in a situation where the wire is really degraded. And the reason is that there are so many other ways to satisfy this situation. I'll have people call me all the time, hey, my house was built in the 40s, the 50s, the 60s, the 70s, even in the 80s, and they're like, oh, we just need to rewire the whole thing. And sometimes that is the case, but more often than not, with the new technology and the awesome breakers that we have now and the different things, you really can bring a home back to life with the new technology and use the old wires that are there. Now, sometimes we do whole house rewires, even later homes that you would not really expect. But so I just really excited about that. So if that's you kind of fall in that category, check this video out, and hopefully we can do a little bit of help you a little bit, give you a little bit of education on it. So I'm going to go ahead and pause the video for just a second and set myself up for the next leg, and we're going to start with number 2. All right, so let's go ahead and check out the second way that you can satisfy the open ground situation, missing ground in your home. So the second way is listed right here in 250.130C. And what we're going to be dealing with today is that it says non-grounding type receptacle replacement or branch circuit extensions, and that's a lesson for a different day. The equipment grounding conductor of a grounding type receptacle or branch circuit extensions shall be permitted to be connected to any of the following. So what this means is we're going to look at these parameters here. Typically, you're going to be in 1 through 4, okay? What you're going to be allowed to do is take a green insulated wire, stranded or solid, and physically fish just the ground wire to the location that you're at. So say if you were at a two-prong situation, okay, and you're over here in your room, okay, you're going to be physically allowed to fish a ground wire just from there to there and then be able to legally install a three-prong receptacle. And there are several different ways that you can do this, and we're going to talk about them. But one thing I do want to note, and that's right here, number 4, is that the one that I'm teaching you right now is in number 4. And one thing I do want to note is that this circuit must originate from the same panel as this circuit. So you are allowed to borrow a ground wire from a neighboring circuit, but it must originate from the same panel. But let's go ahead and get started right with number 1. So number 1 says you can do any accessible point on the grounding electrode system. So anywhere in the grounding electrode system, you can use this wire to fish to that location and then bring it to your receptacle location and be allowed to install a three-prong receptacle there, no problem, and you're going to satisfy the grounding situation. I do want to note that when you get done, and I have other videos teaching you how to do this, that you're going to want to check and verify from hot to ground and just make sure that there is 120 volts or whatever your voltage is. And that way, just to make sure that that ground is all the way connected back to the panel. So number 2 here is any accessible point on the grounding electrode system or the grounding electrode conductor itself. So if you can grab the grounding electrode conductor, you can actually attach to it. Number 3 says the equipment grounding terminal equipment grounding terminal bar within the enclosure where the branch circuit for the receptacle originates. So here's your panel. Here's your receptacle over in this room. You can physically fish one of these wires from this panel to this receptacle location, and now you can legally put a 3-prong receptacle. So that's another way you can do it. And this one says here, which is the one I started out with, number 4 says that the equipment grounding conductor, that's part of another branch circuit as long as it originates from the same panel. So I got a little excited there and got ahead of the game. But say you have a receptacle here, 2 foot over you have a receptacle here. This one seems to have a good working ground. You can actually fish one of these wires from this one to this one as long as these 2 breakers both originate from the same panel. So it's really cool. Okay, so for number 3, we find ourselves over here in Article 406 of the code book. 406 is all about receptacles, cord caps, and attachment plugs. So we find ourselves in 406.4D2, and this is where we're at today. So it's non-grounding type receptacles. That's what they're calling a 2-prong receptacle, is a non-grounding type receptacle. Okay, so number 3, the third way that you can do it, this section here says that where the ground conductor does not exist. I do want to point that out. Remember, this is a location where there's no ground at all. Okay, so where the ground wire does not exist, you can do any one of these things, and we're getting ready to look at them now. So the third way that you can satisfy the non-ground open ground is by replacing it with another non-grounding type receptacle. So you can do a like for like and satisfy the code. So what you're going to do is you're going to come to this location. And you have to be really careful, even as a licensed electrician, because it's easy to get the polarity reversed on these. So you still want to set your orientation with the neutral on the left if you're facing it, okay? That is still going to be silver for neutral, okay? And it's going to be black on brass, okay? My lines are getting a little squiggly there. All right, so when you do this method and you just replace a like for like, you have to be kind of careful when you install this receptacle. And the reason is it's really easy to get polarity reversed. So you still have the hot prong on the right if you're facing the receptacle, and you still have the neutral prong on the left, okay? Always remember that the larger hole is the neutral, okay? And you're still going to have silver over here for the neutral side, and you're still going to have brass for the hot side, which is going to be your black wire typically. But one thing you have to watch, even as a licensed electrician, if you're not paying attention, if you flip that upside down, you can get your polarity reversed. So, and it's a little bit harder to check it with a meter because there's no ground reference. So you're checking across the two. Of course, you're going to read 120, whether it's this way or that way. So that's just something to watch out for when you install these. But the third way to satisfy the code is you can actually replace a like for like, and it still meet code today. The only thing about that is that if you have a buyer, and this is a home inspection report, or if you're doing your own home, they're going to want to see that grounding prong. That's what everybody wants. They want to be able to plug in anything they want to and feel like they're safe when they do it. So that's the only thing about this one. So let's go ahead and take a look at the fourth way. Okay, so the fourth way, when we get into it, it's going to be right here in part B. So it says that non-grounding type receptacles shall be permitted to be replaced with a ground fault circuit interrupter type receptacle, okay? These receptacles or their cover plates shall be marked no equipment ground, and that's really important. We're going to learn about the type receptacle you can use here in just a second. But when you do this method, you must your packaging will typically come with a little sticker that says no equipment ground. And the reason that's really important is because when you look here at this is a dual function receptacle, but it also has GFCI technology. When you look at this receptacle, you're going to see the ground prong, okay? But it's still, even though we've satisfied the code and it is technically GFCI protected, okay, there is no equipment grounding conductor connected to here. So if someone hooks a drill or a sensitive piece of equipment to it, they may want to know that they have that grounding prong there in case of a fault or some other situation. So you have to mark them no equipment ground and have that labeled on the faceplate or right there, okay? But you are allowed to replace it with that, and the code will be satisfied, and you will be a whole lot safer, and I'm going to explain why. So one of the biggest misnomers is that you're required to have this and this connected for a GFCI to work correctly. And in this case, it's just what it is that the GFCI is actually sensing in between the hot and the neutral. And if there's any discrepancy, then it shuts off. You actually do not need the ground prong for a GFCI to work correctly. You do not need a ground at all. It's great to have it because it's going to clear a fault. It's going to allow that current to leak quickly, okay, and the sensing be imbalanced here and it shut off. But you actually do not have to have an equipment ground for GFCI technology to work. Also, you do not have to have an equipment ground for the GFCI technology to carry on. So what this code is going to allow you to do is you are going to be able to install a GFCI at the first location where you do not have a ground. Then downstream from that, you're allowed to hook up a 3-prong receptacle and code still be satisfied. And then downstream from that, you're allowed to hook up a 3-prong receptacle and code still be satisfied. You have to be careful with these guys right here, though. The reason is inside the packaging, some of these brands only allow you to protect so many receptacles downstream before you add another one. So that's the fourth way that you can satisfy the code, okay? Just remember, you have to put the label that says no equipment ground, okay? And you'll put that label on there. Another thing I want to note out is that wherever you're at, most likely the location is also going to be required to be AFCI protected. So you're likely going to want to use a receptacle like this that is AFCI and GFCI protected. But that is something that you're going to have to address with the situation that you're in. Today we're talking about correcting the non-grounding, the missing ground situation. So let's go ahead and move on to the fifth and final way that you can satisfy the code. And it kind of correlates with this one, but it's a little bit different. So this one says in part C, it says non-grounding type receptacles shall be permitted to be replaced with grounding type receptacles. So you're allowed to put a 3-prong receptacle where that circuit's receptacles supplied through a ground fault circuit interrupter. Grounding type receptacles or their cover plates shall be marked GFCI protected and no equipment grounding conductor. So it kind of adds another level there. You're required to put another sticker. Basically, it's saying the same thing. You can protect it with one of these, but the fifth way I want to show you, and the way that we use most often in the field, is through one of these. This is a square D version. And what this is they sell breakers. This one may be arc fault or ground fault only, but I just use this as an example. So they sell breakers that you can actually protect the entire circuit all the way from the panel. So let me explain how this works. So you would install a breaker like this that's GFCI protected. And like I said, you're likely going to be in an area that requires AFCI protection, but no worries because they sell a breaker that satisfies arc fault and ground fault, so you'll be super protected all the way from the panel. So say I'm back here at the panel, I go install this breaker right here, and everywhere that this wire leaves is now AFCI and GFCI protected. So at every single one of those locations, I can legally install a 3-prong receptacle, okay? And everything be satisfied with code, my potential buyer, the electrical inspector, and I've done everything correctly. What's awesome about this is it allows you to do one thing, and I have videos on this. Remember, never repeat anything in these videos, just use them for educational purposes only. But now you're protected and can install a GFCI receptacle, or a regular receptacle, a regular 3-prong receptacle at each one of these locations and be satisfied to code and be a whole lot safer for the situation. One thing I want to note, whether you're using this method right here or this method right here, okay, what you're going to want to do is after you get this installed, so say we came here, we've installed our breaker, we've gone to 1, 2, 3 receptacles. After you get this installed or this installed, either one, what you're going to want to do is go back to the first point where you installed the GFCI protection, and you're going to want to hit this test button. And you're going to want to hit this test button right here. And the reason is you're going to want to make sure that these receptacles downstream do shut off when that test button is pushed. So if installed correctly, okay, when you hit that test button, it's going to shut off everything downstream from it if wired correctly, okay? And that is going to let you know that you've done your job. So I hope that you guys enjoyed this video. Please like and subscribe for more videos. I'm trying to build the world's largest library of free electrical installations. We just want to see you guys win. You can check out the Electrical Code Coach channel, which is geared more toward the code side of things, or you can check out the Electrical DIY Coach channel, which is where we're going to build the world's largest library of free electrical installation tips and tricks videos done by a professional. Remember, never repeat anything in these videos, and I hope that you guys stay safe. If there's anything I can do to help you in life or business, please let me know at electricalcodecoach@gmail.com. Thanks, guys.